All right, how'd the homework go? Easy, excellent, excellent, excellent. You want another easy one?
Yes.
Too late. There are no more easy ones. All right. Today you're going to get two new rules. They are not impossible. They are easy to understand. It's the doing it that it's very messy, right? And then tomorrow we'll practice everything we've learned so far. Tomorrow's just a straight up practice day, nothing new. It'll be 60 questions to practice on, right? And then we'll do a review, an AP review, to see how these questions look like on the AP test. All right, homework tonight.
Then the sun.
All right, Ben. Jace, we're giving you a special message. You can see this picture in the email. All right, good, everybody? All right, here we go. More formulas. Last class, we learned basically one formula, although it had a lot of different special cases, right? But the day arrived that you should be happy, not like this guy, right? You should be happy the fact that the power rule is pretty straightforward and easy to use. No more use of the limits to find derivatives. We have a nice formula to get us to some derivatives. I will let you decide whether you need to write this down. I'm going to be asking you the answer to derivatives the entire day today. So the power rule, right, is this one. And then we have the special cases of the power rule. If it's just a constant, that's a horizontal line. Horizontal line has a slope of 0, so therefore the derivative is 0. If it's just plain old x, well, the derivative of x is 1. And then the last one, if it's a constant times a monomial, then you take the derivative of monomial and multiply it by the constant, or n times c, all right? So this is just a repeat of that one slide from yesterday. These are not the new formulas. And since there was no questions on the homework last night, I'm assuming that you have good knowledge of these, good command of them. All right, we also had the sum and difference rule. That just basically says if you have a polynomial, you can break it up into individual pieces, take the derivative of each piece by itself, and then apply addition or subtraction depending upon which one it is. Lastly, what's lost in all the conversation we have about derivatives or calculating derivatives is the fact that the big picture is
what is what are you really doing?
What are you really doing?
Finding the slope.
We're not just finding the slope, we're finding
Slope of a tangent.
And not just that, we're finding all of them. All of them. Given a curve, right? When you take a derivative of this function, you're not finding one slope of a tangent, you're finding all of them. So when you take a derivative of, in this case, a polynomial, you get a different function, right? And that new function allows you to calculate the slope of any point along the curve, right? It's hard to see because of the projector right here, but here's your function. What's the derivative?
4x to the third minus 12x plus 1.
Nope. Constants will always result in a 0. So just 4x cubed minus 12x, right? And remember, this is the one we did yesterday, this W looking thing right here. And when you take the derivative of this function, what you just told me right there, this will tell you what the slope is on any point along the curve. Pick a point, any point.
0.
So if we why do kids always pick 0? It is. When I pick the x value 0 on the original function, remember the original function is x to the 4th minus 6x squared plus 4. When I pick the x value 0 and I draw the tangent, clearly it has a slope of
Zero.
0. And that's what would happen if we throw 0 into the derivative. All I'm doing is taking the derivative, I'm letting x be 0, and clearly I get the answer.
Zero.
I get the answer 0. But what if it was a different point? Give me another number.
5.
Okay, I thought you were going to say
One.
1 or 2. So I'm going to pick 2 right here. Do you see where 2 is? This is the x value 2 where I put this red dot. Yes? Right, you got to trust me, it's 2. What do you think the slope is? Take a guess. What do you think the slope is?
At 2.
By observation, look at the black line. What's the slope? 4. Oh, clearly bigger than 1 and not negative, right? So how could we figure out what it is?
By plugging it in.
We just plug in 2 to the derivative formula, right? The x value 2 into the derivative form, not the original function. We plug in the original function, it'll tell me the y value. Here, the y value is negative, right? The original function, you see that? The y value would be negative here, 0. The y value would be negative. But for the derivative, it's the slope. So it should be a positive number. Let's see. What do we get? We get 8. And 8's a positive number. One more?
Yes.
Pick one.
5.
Thank you for picking 1, right? So at 1, do you think the slope is positive or negative? Just look at the line. Negative. Take a guess what the number is.
Negative.
Don't do the math. Just look at it and take a guess.
Negative 5.
Negative 5. All right. Let's see. How can we figure out what it is?
7.9.
We just plug 1, because 1 is the x value of this red dot right here. We plug in 1 into the derivative formula and we get,
-6.
no, we don't.
-8.
We get -8. Okay. So what are you doing when you take a derivative?
Finding the slope of n.
You're getting a
and
function that gives you the slope of any point along the original function, right? Or the slope of the tangent along any point along the original curve, right? Don't ever forget that. Lastly, remember, we'll only do the first 3, but if I give you the position function, which is typically called s of t, right? And take the derivative, that gives you the velocity function, v of t, or s single prime or f prime. And lastly, if you take the derivative of velocity, you get acceleration. Okay? That was your word problems, right? All right, ready for the new stuff? Happy? Happy? You ever seen these videos on YouTube? It's the Rottweiler and the leopard.
The leopard. I thought that was a dad.
No, that's a big leopard. This cat's bigger than that dog.
That one looks like my cat.
Yeah, that's a big cat. That's an eat a human type cat. All right, 2 more rules today. Yesterday we saw the sum and the difference rule.
Multiplication, division.
Yeah, but there is a multiplication division rule, so let's give them some love. And since the power rule is easy and the addition subtraction rule is easy, you would expect that the multiplication rule or the division rule would be easy as well. But in fact, unfortunately,
It's hard.
it is not easy. What is easy is the understanding of what you're doing. I know what to do. The hard thing is it requires a lot of simplification. There's going to be a lot of like little individual algebra steps. Okay, I got to prove this to you. I can't just say this is the rule. So here's quick proof. Although most would argue this is not a quick proof. So I'm going to let capital letter F represent 2 functions that are. So that's why this is called the product rule. So I want to take the derivative of that. In other words, I'm going to let capital F of x, right, equal, I'm going to find its derivative. So we go back to, once again, whenever we prove things, we go back to our definition of what a derivative is. It's the limit as h approaches 0 of the difference quotient, right? Okay, cool. So what do I need to do? What did you do with this in the past?
Solving.
Yeah, but what do you physically do with it?
Put the top thing into x plus h.
Other way around. It's not that I put the function into f of x plus h. I put x plus h into the function wherever I see an x. Where do you see an x?
I have to do that f of x.
Right. So now that's going to become
F of x plus h
times
g of x plus h
minus.
minus f of x plus h times g of x.
We're just plugging in x for the second
No.
one.
No, not plus h.
Just f of x times g of x. Right. See what I did? Yes. Cool. Now what? Is there anything we can do here? Is there anything to multiply? Anything to simplify? And the answer is no, there's nothing you can do there. It's fully simplified. There's no powers here, it's functions. So there's literally nothing we can do. So, well, if there's nothing that we can do, then this must be the answer. But I said there's a rule, and that doesn't seem like a rule. So we're going to reach into our and pull out a trick, right? You've never seen this math trick before. This is a new one for you. All right, we've seen tricks where we multiply top and bottom by the same number, but we change the number around. We multiply by 5 over 5, or x plus 5 over x plus 5. Multiply by the conjugate. We've seen that trick. This is a brand new trick. You ready for it? This is called, I'm going to do nothing. You ready? I'm going to do nothing. Give me a number.
1.
If I start with the number 2 and I do nothing, I will end up
2.
with a 2. So I'm going to subtract 1.794. I said I'm going to do nothing.
Take the derivative.
No. You said 2 and I said I'm going to do nothing. So my answer should be
Plus 1.
plus 1.794. So well, guess what I just did?
Nothing.
I did nothing. I started with 2. I finished with 2. Now the question is, how do you know what the nothing should be in this case? And that's why we are in a high school calculus class and we're not geniuses. Somebody, a genius, figured out this is what we should do. So what I'm going to do is I'm going to subtract something and then add it back in. So in that case, I've done
Nothing.
nothing. Here's what I'm going to, it's time for a trick. This is what I'm going to do in color. What did I just do?
Kind of like a conjugate, but not.
Kind of like a conjugate, but not. But guess what I ended up doing?
Nothing.
Nothing. I'm subtracting this mess in red, but then I'm adding it back, so I've accomplished nothing. Except I have accomplished something. You ready for this?
Yeah.
Okay. Now, where did they come up with this? Can't give you the answer to that. Somebody smart said, "Hey, this is what we should do." All right. So this is what I'm gonna do now. I now have 2 parts to a fraction. I got the red part. I got the blue part. Am I allowed to separate those into 2 separate fractions?
Yes.
Yeah.
As long as I put them over. So I'm going to do that, right? I'm going to put that. And I want you to notice in the first fraction, the red one, in common, I have an f of x plus h in both ones. And in the blue one, I have in common g of x. And the reason why I added and subtracted that one is so I could do this, okay? So I'm going to separate it into 2 fractions, see what I did, see what I did, see what I did, right? And then I'm going to factor out the common thing in each fraction. The one on the left, what's the common thing? And on the right?
G of x.
Okay, so I'm going to do that. See what I did? When you factor something out, you do it with division, right? So multiplication would make it back to its original form. You okay?
Yeah.
I need a new sheet of paper now. So I'm going to take the bottom. I'm not changing it. Trust me. And there it is. Hey, we are taking a limit. One of the properties of limit says that if you have a function added to another function, you are allowed to. Got a limit. And I got a function added to a second function. So I'm allowed to. I got a other way around. I can separate them. I can take the limit of the first plus the limit of the second one, yes? So I'm going to do that because there's a plus right there or a minus, whatever, right? So I separated them. But do you see what else is here? I put it in here this time. Do you see the dot?
Yeah.
We have a rule that says if you have a function times a function and you're taking a limit, you can separate them as well too. So now I'm going to separate with the multiplication. Oh boy, this is getting longer and longer and longer, right? But now watch the magic. Here's the trick. Oh, go hold that thought. Look at the first thing. What does it literally say?
That's an x plus h.
Well, then could we not plug in a 0 now? What would we get?
Fx.
Okay. And what did he say? Which I said to be quiet. This is just the derivative. Look, it literally says the limit as x goes to h of g of x plus h minus g of x all over h. That's the formula for the derivative of g of x, not f of x, but g of x. So this thing right here, oh, I'm sorry, over here, I did the red thing first.
Yeah.
Well, there's no h.
Yeah.
So if there's no h, then remember we have that rule that says the limit is whatever is written right here, and that's g of x. Okay, now back to this. So that is the limit of g of x, or the derivative of g of x. And the one here over here, which I made blue now, is the
F prime of x.
f prime of x, right? So what goes between all this stuff?
Multiplication.
Well, multiplication because of this right here, and then an addition. So guess what this is?
The form.
This is the formula for
Multiplication.
the product for multiplication. What does it say?
F of x times g prime of x plus g of x times.
It's kind of like a poem. It kind of flows, right? It's a song lyric or something like that. We'll write this down here in a second, but this is it right here. By the way, on your plastic sheet of paper, that's what's on there for the product rule, right? This is called the product rule. Don't write this down. This is how it's written in the book. Remember, we can write derivative many different ways, and they chose d over dx, right?
The worst way.
They do. So that's why I say don't write this one down. I like this one even better. Just leave off the x because the x is kind of there for, it has to be there in terms of doing the math, but I don't need it for understanding of what comes first, what comes second, what's in between them. So I like this one. They do. They do. So you take f and you multiply it by plus g times. You think you're going to mess this up?
Yes. Probably.
100%. Look, it goes f, g, g, f, and then there's two primes, and you're going to forget where the prime goes, which is why you have that on your resource card. I will say if you do this enough, you will have this memorized. This is the one on your resource card, the one on the bottom. I like the yellow one. I like the yellow one. And the x's just kind of get in the way a little bit. And this is called the product rule. And if you can remember what's written in yellow, then this is a straightforward process of setting it up. It's the doing it that requires a little bit of manipulation of numbers and taking derivatives. Of the two rules, the product rule is much easier than the quotient rule. Good, everybody? All right. So, talking about the details, how do you actually do this? So if you're actually asked to take the derivative of capital F, right? I have a first function, I have a second function, yeah? Okay. So f prime of x is listed as this. So let's see, it says take the first function and multiply it by the derivative of the second function. So the first function times the derivative of the second function plus, follow the pattern, second function
First.
times the derivative of the first. So these are the mechanics. What you actually have to do to get to an answer. Good, everybody?
Mhm.
Very good. Okay. Let's do one. Here we go. What's the formula say for product rule? Somebody, what's the formula? We're going to sit here until somebody says it.
F times g prime plus g times f.
Okay, so that's what the formula says. You need to decide what's the first function, what's the second function. What's the first function?
6x.
And the second one is the second one. So first one we'll call F, and the second one we'll call G. All right, Wes, you're in the first.
So we grab 6x to the third and multiply it times 28x to the third.
Everybody see where you got that from? Plus
7x to the fourth times 18x squared.
what's left to do?
Let's multiply.
I'm gonna multiply. Let's see, 6 times 28, 6 times 8 is 48, carry 4, 6 times 12, 6 times 2 is 12, plus 4 is 16, so 168, x to the
6.
7 times 8 is 56, carry 5, 7 times 1, 7 plus 1 plus 5 is 12, so 126, x to the what?
Oh,
6.
X to the 6th. Hey, it's by coincidence, then this typically doesn't happen. Look, we got the same power, so we can actually add these together. Let's see, what do we get?
92.
290.
4.
Yeah.
Pretty simple.
It is, but not one you can do in your head, right? We can always do the power rule in our head as long as the numbers are somewhat friendly, but the product rule and especially the quotient rule, you can't do these in your head. Anybody want to make a comment about this? Did we get to an answer?
Yeah.
We claimed it's 294 x to the 6th. You might be thinking, couldn't I, from the very start, couldn't I just multiply and then take the derivative? Well, let's see what happens. Multiply. Multiply. Come on, 6 times 7.
42 x to the 7.
Okay, and then we have to 7 times 2. Carry your 1, 7 times 4.
It doesn't work.
Okay, it does work, right? So you are correct. It would work, right? The but here is this.
It doesn't work every time.
It works every time. Unless
There's some.
unless
There's trig.
unless
There's-
you can't multiply them together.
Yeah.
Right? And get an answer, right? I mean, clearly I can multiply x squared times sine x if I know what x is. But if I don't know what x is, I can't multiply them together. So listen to me carefully. Tonight for homework, you can multiply them all together. So do I want you to multiply them together? No, because I want you to
do it right.
practice the product rule. But after today, on a test or whatever, finish the sentence. After today, you can. But tonight for homework, I need you to practice the product rule. Because very quickly, we'll have ones like this one, you're going to have to use the product rule. Does everybody understand the point I made there? Okay. Clearly, you can multiply these together, get the same answer, and that's how you should do it after today. Okay? So tonight for homework, right, use the product rule. Use the product rule, right? Understand that it is easier to multiply the two terms together and then take the derivative, and that's how we'll do it in the future. Unless we can't multiply them together, like in this particular one right here. And since you don't know what the derivative of sine x is, you couldn't do one like this. And that's not one tonight for homework. Right? All right, do another one. All right, Kyle, you got the one on the left? Go.
8x.
Oh, well, okay. So the first thing we gotta do is decide which is f and which is g.
That one's F though.
Okay, so most people say the first one's f. By the way, it would work either way. The quotient one, it won't, but for product, because multiplication is commutative, you can do it either way. All right, so what did you want me to write?
X cubed times 2 plus 2x minus 1.
Oh, she's saying it really quick. 2x minus 1 times.
3x squared.
Okay. And now,
2x cubed plus 6x cubed minus 3x squared.
okay. Last,
8x cubed minus 3x squared.
it seemed awfully quick, and that's because she already did it while I was talking. Right? She wasn't doing it while we were doing it. All right, Addie, did you already do it or no? Okay, cool. So start us out for the second one.
Squared. Yeah, x squared minus 1 times 1.
Oh, that's convenient. Do I really need to do that? No. Plus
Plus 4
times.
2x.
So what do we get?
X squared minus 1 plus 2x squared plus 8x.
Okay. Final answer.
3x squared plus 8x minus 1.
Okay, cool. And once again, if we're using the product rule, we can't do that in our head, right? By the way, would you go to the, now that you know that there is a different way to do it, would you go to the hassle of actually multiplying this out and then doing the power rule, or would you just say, I'm going to use the product rule?
I would
You would still even on this one? The binomial one?
Yeah.
I probably would do product rule for this one. I think it's the same number of steps. It's no faster, no slower, right? For this one, absolutely positively, I'm distributing and using the power rule, right? But for the binomial times a binomial, it's probably just as quick to use the product rule. Now that assumes you remember the product rule. If you have to look it up, then no. All right, the second one, for sake of time, I'm not going to prove this one for you. However, the proof is on page 136. This is the bear. This is the bear. This is the bear. Right? There used to be a show called Gentle Ben that had a bear in it. Are you gentle?
He's a gentle giant.
All right. We're just going to write it down. This one is ugly. All right. So there is the quotient rule. I made it color coded to try to help you a little bit of what is the top function, what is the bottom function. Red is the top function, blue is the bottom function.
This one be on a test.
Oh, yes. Oh, yes. And they get worse. We won't talk. I don't want to give you nightmares yet. All right, so how are we going to remember this one? Right? This is as simple as it gets if you want to write in really simple code right there. The book recommends that you remember it in the following manner, right? I don't know if this is helpful for me, but maybe it's helpful for you. They say low d high minus high d low over the square of the low. So what does that mean? It means you start with the thing in the denominator, that's low. D means derivative, then derivative of the high function or the numerator minus, right, the high function or the numerator times the derivative of the low function or the denominator all over the denominator squared. So low d high, high d low, or low d high minus high d low over the square of the low. This one, 100% you can't do it. I mean, there's no possible way. It's just too much to do.
I'm gonna do it.
I have never seen a student do this in their head, unless it's such an easy, like it's 2, but you're going to put it as 2 over 1.
Yeah, I'm not doing
And then the derivative is 0. All right, ready to do one? Ready to do one? It's just like baking a cake, right? We have a recipe, we follow the recipe. By the way, for both the product and the quotient rule, we add one caveat, and that f and g must be differentiable. This does not work if they're not differentiable, clearly, right? All right, here we go. There is my formula. Who are we on, Ben? So what do I write?
So
Well, we got to decide which is F and which is G.
top is F.
Top is F, the bottom is G. Now we just do our recipe right there.
So G times F.
Well, what is G?
Bottom.
Which is
So it's x cubed plus 6
in parentheses.
times 2x plus 1.
Okay. In parentheses.
Yep.
So you can already see how this is going to go badly. I got a binomial times a binomial. Minus
X squared plus x minus.
in parentheses or not in parentheses? In parentheses. Make sure you put those because that minus is going to be distributed to everything on the inside. Times.
In parentheses 3x squared.
Okay. All over.
X cubed plus 6 squared.
Okay. We can see the complexity already emerging. Now we got to do a bunch of scratch work off the side. What do you want to do first?
Denominator.
We will never simplify the denominator. Leave it that way in the hopes that something cancels. Maybe there's going to be an x cubed plus 6 we can cancel out. We'll see.
No, G prime times F.
Okay, so what do we get? 4 arrows.
2x to the 4
So we get 2x to the 4th.
plus 8x.
What?
No, plus 12x.
Thank you. And then the 1
Plus x cubed
plus x cubed
plus 6.
plus 6. And then can you do this, or do you just want to distribute it and then do the minus sign?
Distribute.
Just for the minus sign, so what would you get?
Or
3x to the 4th
plus x to the 3rd
minus
6x squared.
Okay, so this is what you just said, yeah? With a little bit of scratch work. Woo, that's a lot of things. I'm not going to distribute, I'm just going to do it all in one step. I'm going to go to the highest power, which is 2x to the fourth, I'm matching up with an x to the fourth over here, which will give you negative x to the fourth, then do the x cubes, negative 2x cubed, then do the x squares, there's only one of them, be careful,
Plus 6.
plus 6x squared because of the distribute the negative, and then do the x,
Plus 12x.
and then do the constant.
Plus 6.
There we go. And it's yellow, therefore that must be the answer, because how do you factor that thing on the top? Not a clue. Right? And I mean, we can figure it out. We did a freak out. But that's perfectly fine. Guess what the hardest thing to do for homework is?
That.
No. The hardest thing for homework is you're going to get to an answer and you're going to look at your answer sheet and you're going to say, wait a minute, did I really get the answer? 9 times out of 10, your answer may not match the answer in the book. You're going to have to manipulate it some way to confirm it. We'll do one I'll show you tonight for homework.
Your note sheet says to take 2 derivatives. So it's that.
It's wrong, and they noticed that period 3. Thank you for that. You know why? Because the previous one handout it said double derivative, so I fixed it though. Jace, for you, it'll be correct. The thing I emailed you. All right, cool. Makes sense? Do one more. All right, we're back to Wes.
Derivative is x squared, 3x squared.
Start with G.
Well, it's just gonna find the derivatives first and then.
Oh, so some people will do that off to the side, put a little box or something and find both derivatives, but make sure you label it correctly, right? And then you copy it over, that's fine.
But
Okay.
that's 2 for so 2x.
So let's see, G prime of X would be equal to 2. And then F prime of X would be equal to
3x squared.
3x squared. Okay, now plug things in.
2x plus 1 times 3x squared is 2 times x.
And remember, it's a minus.
3 over 2x plus 1 squared.
Yep, everybody? You like his method? Fine. Now what?
Let's multiply it out.
All right, do it.
6x cubed plus 3x squared
Okay. Distribute the 2
minus 2x cubed minus 6
plus 6.
plus 6.
Right. I didn't do that. I left the minus on the outside. Then when I put it together, you can use this technique or the one you use, just you drop the negative there on the 6. All right, final answer.
4x cubed plus 3x squared plus 6 over 2x plus 1 squared.
There we go. There's the quotient rule. Yeah? Addie? Okay. Lastly, this. Only use the quotient rule when it makes sense after today. After today. Tonight for homework, I want you to use the if they're asking, if they give you a fraction, you use the quotient rule every time. Okay, I'm gonna show you one, right? You see this one?
Yeah.
Tell me something smart.
Can factor out an X.
No, can't factor out an X.
I don't know.
But that would be viable too. Always simplify first if you
If you
can.
multiply the top by the bottom. and take the
Yep.
derivative,
So how can I move the bottom to the top?
By X.
No.
Oh.
Yeah, I want to move the bottom to the top, but what would that do? X to the negative 1, right? So yeah, let's do that and then distribute. Remember, after today you can do this, not tonight. Now distribute this x to the negative 1 to the inside. Somebody, anybody,
3x
keep talking.
plus 2x to the negative.
And what would that do to the negative 1? Don't do it yet, because remember, this is just the distributive property. Now we want to take the derivative. So take the derivative of this now. Keep talking.
Minus
No, or yes, sorry. Yes.
2.
X to the
2.
negative 2. Could we move this again?
Yeah.
Move this to the
Bottom.
bottom, and yeah, that's the answer. Once again, this is what I would never, if you have a monomial in the denominator, ever use the quotient rule. It's just too challenging, right? Too easy to make a mistake. If you have a binomial, well, then you don't want to do that, right? But if you have a monomial, yeah, absolutely, move it to the top after today. After today. Yeah? Okay. Homework right here, Jace. We're gonna do number 14, and you're just gonna hear me talk through it. It won't be on the board. All right. Somebody read me number 14.
Cube root of x.
Is it f of x or y or something?
Y equals of x multiplied by 2 plus x
In parentheses.
in parentheses.
Just like that?
Yep.
Yep.
Okay. Product or quotient rule?
Product.
Product. Okay, what's f and what's g?
F is cube root of x, g is 2 plus x.
All right, you're on. What do we do?
Find my primes. Wait,
Okay. What's f prime?
prime is
Oh, how do we do square roots or cube roots?
it's just negative 1/3 is the
Not negative 1/3.
it's 1/3.
It's 1/3, right? If it was on the bottom, it would be negative 1/3. So let's see.
So you get
Cube root of x would be x to the 1/3, right?
is it negative.
Where are you getting a negative?
Well, I'm subtracting 1.
That's not what you do first.
You put it up by front, so 1/3.
So 1/3 x to the
negative 2/3.
negative 2/3. Okay. And g prime.
1.
Okay. All right. What's the formula say?
F.
So what's f?
F times.
So what's f?
Cube root of x
Cube root of x
times 1.
times g prime, which was 1. So do I need to put 1?
No.
Okay.
And plus.
Plus
1/3 x minus 2/3 times 2 plus x.
Okay. What do we need to do now? What?
Factor it out.
We're not factoring
Let's
anything.
multiply.
Yeah, just distribute.
So
So we got cube root of x
plus 2/3 x minus 2/3
Okay.
plus
Ooh. What do we get there?
1/3.
Oh, okay. 1/3.
And 1 to that, so plus 1/3 x. No,
I think you just need to say it.
x to the 1/3.
X to the 1/3. Everybody take a look at that. You got it right. Take a look at that and see if you agree. You see where he got all that? All right. What's the answer say? This?
No.
Guess what the hardest thing when you do this stuff is? I already said it once. Guess what the hardest thing is?
Negative.
Negative.
No. Figuring out if you actually got the answer or you made a mistake. Because I'm not telling you the steps, I'm just telling you the answer. So the question is, do you think this is the answer, or do you think we just missed a step? Or did we make a mistake?
I think I missed the step maybe.
There's one extra step we could do. What's the one extra step we could do?
2/3. Make the cube root of x. Make it 2/3.
Make this not 2/3, make this.
3.
3.
Well, the first before you do that, you're telling me an answer, but you're not telling me the step. Make this. How did you get 2/3?
Make that
You read it
x,
off.
one of
X, make this x to the 1/3. So if this right here is x to the 1/3, and I got another one sitting right here, right? What do I get?
4/3.
Well, I need a fraction in front of the x.
So 1/3.
So 3/3.
So 3/3, right? Which would be 1, right? And if I add this to this, I get,
4/3.
Which means it is the answer.
hold on, 4/3 x to the 1/3. And then I get this, plus 2/3 x to the negative 2/3. Okay.
That is the answer.
And is that the answer?
Yeah.
So like I said, you're going to get to this and you might be thinking you made a mistake, or you might even get to here and think you're done. And you're like, what? That's the answer? What did I do wrong? In fact, you didn't make any mistakes. You just didn't fully simplify it. That's typically the hardest thing is convincing yourself you did it right, but you just simply didn't take it as far as what the book answer is. Did that make sense?
Yeah.
That's probably the hardest one tonight for homework, and we just did it. Cool. All right. That is it. Hope you're enjoying your vacation, Jace.